Welcome to Okunko Academy. So in this video we are going to talk about applications of partial differential. So now I will recommend that if you are new to this channel, you like and subscribe, and also you put us on post notification so that you always be notified on every new video uploaded. Now moving on to today's lecture, we are going to consider applications on tangent planes and linear approximations. So now someone may ask, what's a tangent? So now in our high schools we know that tangents are lines that touch a curve at one point, but in this lecture we are considering planes. So when we talk about planes, we need to broaden our scope to a 3D dimension, that's in the x, y, and z. So now let's consider a small curve here, and now this curve is in the x, y, and z. So where the x, y, and z intersect, they are definitely going to intersect at one point, and that point becomes our tangent. So now we are looking at a way of finding the equation of the tangent to a line. And now this one is simplified into an equation, and that equation is, we have our z is equal to our f of x naught y naught plus fx of x naught y naught multiplying x minus x naught plus fy. So now the fx is the fx here is the partial differential of f with respect to x, and the fy here is the partial differential of f with respect to y. So now, having our general equation, let's quick start with first example. So now with this first example, we are concentrating on how to find the equation to a tangent plane. So now the example here, we have a function of f of x and y, and that function is defined as 2x squared minus 3xy plus 8y squared minus 4y plus 4. And we are saying this curve has a tangent, and that tangent touches a point at 2, -1. So now the x naught and y naught here basically represent our point. So our x naught is 2, and our y naught is the -1. So now with our equation, it means that we first need to get this term, and secondly we get this term, and lastly we get this term. So now let's do it chronologically. Let's do it step by step. So now with the first one, that's easy to evaluate. So now we are just evaluating f of our point, and our point, we have 2, -1. So now let's put it in our general equation. Now we have 2, our x is 2. Now we have 2 squared minus 3x, and our x is 2 times y, and our y is -1 plus 8 y squared. So our y is -1 squared minus 4y, and our y is -1 here also, plus our constant, which is 4. Okay, now let's evaluate. We have 2 squared. So now 2 squared times 2 gives us 8. And now -3 times 2 gives us -6. Now -6 times -1 gives us +6, because we know nege 4. So now plus 6. Okay, now -1 squared gives us +1 times 8, so plus 8. Now -4 times -1 gives us +4 plus our constant. So now let's evaluate all. we have 8 plus 6 giving us 14. Now 14 plus 8 giving us 22. Now 22 plus 4 gives us 26. Now 26 plus 4 gives us 30. So now we are done with the first term. So simple. Now let's go to the second term. Our second term is the partial differential of f with respect to x. So now let's differentiate this function with respect to x only. That means that any y term is treated as a constant. So with the first term we have 2x squared. Now 2x squared, we end up getting 4x. Now negative 3xy, differentiating, we have negative y because our y is constant. Now our 8y squared goes to 0, 4y squared also goes to 0, then our 4 also goes to 0. Now let's evaluate the point. So now the point, we have 2, negative 1. So we have 4 times 2 minus 3 times negative 1. So now 4 times 2 gives us 8. Now negative 3 times negative 1 gives us positive 8. Now negative 3 times negative 1 gives us positive 3. Now 3 plus 8 gives us positive 11. Simple as that. Now moving to the last term, that's the partial differential of f with respect to y. Now differentiating the function up, our 2x squared goes to 0, and our negative 3xy becomes negative 3x. And now our 8y squared becomes 16y. Now our negative 4y becomes negative 4. Now let's put in our points. Very simple. Now with our point, we have negative 3 times 2. Now we have 16 times negative 1. Now minus 4. So now we have negative 3 times 2 gives us negative 6. Now 16 times negative 1 gives us negative 16, adding up to give us negative 22. Now negative 22 minus 4 gives us negative 26. So now we have all the 3 terms here. Now let's write our equation. So we have z is equal to our f, we had it to be 30, plus 11 times x minus 2. Now we have f of y to be negative 26. That is times negative 1. So now let's expand. Now expanding this, we are going to end up getting 11 minus 26y. So now evaluating the constant, we have 30 here. Now 11 times negative 2 gives us negative 22. So 30 minus 22 gives us 8. Now 8, we have negative 26 times negative 1. So now 8 plus 26 gives us 34. Now this becomes our equation for the tangent. Now having understood this, we are going to move to the second application. So now with our second application, we are going to focus on linear approximation. Linear approximation. So now with linear approximation, we are going to consider only one example. So now the example here, we have a function f of x, y, and now that function is defined as e exponent 5 minus 2x plus 3y, and we have to approximate a function of 0.4.1, 0.9 using this 0.41 to 4 decimal places. Now in this question, we are given a point to use, that's 41. So now you may ask yourself, what if we are not given a point? So now if you are not given a point, the best solution is to approximate the function given. That's the function you have to approximate. Just approximate the coordinate to their nearest whole numbers. So now approximating 4.1 gives us 4. Now approximating 0.9 gives us 1. Okay. So now with the same idea from the tangent, let's quick start. So we are first going to evaluate the function. It's our point 4, 1. Simple as that. Now we have 5 to the power 5, e to the power 5 minus 2 times x, and our x is 4, plus our 3 times 1. So now we have 5 minus 8 giving us negative 3 plus 3 gives us e to the power 0, and we know in mathematics any number to the power 0 gives us 1. Thank you. Now we have to evaluate the partial differential of f with respect to x. Now differentiating the top function with respect to x end up giving us negative 2. Now e to the power 5 minus 2x plus 3y. Now evaluating this, that's by substituting in the point, we end up getting negative 2 multiplying e to the power 0, similar to the top one. We end up getting here negative 2. So now differentiating f with respect to y gives us positive 3 e to the power 5 minus 2x plus 3y. So now this one also gives us 3 multiplying e exponent 0, and now we also end up getting here to also 3. As simple as that. Now going back to the equation, we get our actual equation to be z to be equal to 1 plus negative 2 times x minus the point 4 now plus 3 we have y minus the point 1. So now evaluating this, we have negative 2 times x gives us negative 2x. Now plus 3y. Now let's evaluate the constant. We have 1, negative 2 times 8 times negative 4 gives us positive 8. That's 1 plus 8. Now minus 3 gives us 5. Now this is our equation we are going to use to approximate our point 4.10.9. So now let's approximate the point. So let's substitute. We have negative 2 times 4.9, sorry, 4.1 rather, 4.1 plus 3 multiplying 0.9 plus 5. So now our z becomes, so now evaluating this, we are going to end up getting that's negative 0.5. Now the question said 4 decimal place, so 0, 0, 0. So now you can get similar examples. You still need to go through with the same approach. So now here I did a little mistake here. So now here becomes y plus 1, not minus. So therefore our constant only changes. So now with our constant we had 30 minus 22 minus 26, and that one gives us negative 18. So now with my viewers who are very observant are going to observe that we had a mistake here and they are going to correct it. Now thank you for your audience. See you in our next tutorial video. Bye.